All right, so now that you've had the opportunity to try out this last unit 9 review, again, it's not the entire test, but these are some of the concepts that I feel we didn't cover enough in class. And since we're going to see something similar on the test, we should cover it now. So, first question, right? And by the way, one of the best things you can do right now is just sit back and just watch, right? Just take it in, get an understanding of it. Don't worry about writing this stuff down, anyways. It's just a review to get you into math mode as usual before you take your test. So, condensing. When we are condensing, that means right now I see two logs written out. It is my goal to just have one log. So, this is why my word wall comes in handy. It has all the properties. So, whenever you do expanding and condensing, this is what we use for expand and condense. These are the rules here. If we see multiplication, then it's addition. If I see addition, then I turn it back into multiplication. So they go back and forth between them. It works the same for natural logs. Keep in mind, ln is just a log as well. We have our minus sign with a division. And of course, if we ever have a power up here, notice it means there was a number in front. So we can always bring down a power to the front, or if I see a number in the front, I could send it back up to a power. In fact, that's the very first rule we're going to apply here. Whenever they want you to condense, it means turn it into one log. Well, I can't yet. See, when I see the word log, there's numbers in front of them, and that doesn't allow me to bring these two logs together yet. I basically need to take that 3 and send it back up to a power, take that 2, send it back up to a power. So now it says log base 9 of x to the power of 3 minus log base 9 of y to the power of 2. Again, the minus sign means division is coming later. But first of all, we now have no coefficient, no number in the front, which means I can now take these two logs and basically turn them into one. So we write the word log, base 9, and then everything is going to go in a parentheses. And that's the one thing you need to remember. Put a parentheses right away so that you don't accidentally write the word log again. We should only see it once. But now let's look at what we had left over. The first thing I see is an x to the 3. Well, then I know there's an x to the 3. That's the first thing I'll write. The minus sign, according to our properties, means that we're going to be dividing. So throw a division symbol. And then what's after the division symbol? Well, there's a y squared. So then I'm dividing by y squared. And just like that, we're done with this problem. Look, honestly, the one thing to remember is if you have a minus sign, like the y squared had a minus sign in front of it, then that belongs at the bottom of a fraction. So it doesn't matter, even if I put a negative in front of this one, then they would have both been at the bottom of a fraction. So again, the minus sign just means put it at the bottom. For instance, look at number 2 now. Number 2 is very similar. Now, it does have a negative, but there's no other numbers, just a negative 1. This one has a 1 in front, so it's okay. But there we go, look. We have a 6. I have to send it back up to the top. Right now, yes, they all say log base 6, but I cannot turn it into a single log because of this 6. So I'm just going to write it out. Log base 6 of x, log base 6 of y, plus log base 6 of z to the power of 6. See, so now we're ready. We have a log with no coefficient except a negative, a log of 6, a log of 6. I'm going to take all 3 of those and just write it once, which is the idea of condensing. Remember, you write it once and then put a parentheses. Everything else goes in here. Yeah, there's a negative, there's an x, there's a plus, there's a y, there's a plus, there's a z to the 6, right? All of these things, as I go, I'm going to write them down. So let me show you what I mean by that. The negative in front, well, then that means I need a fraction. So let me get my fraction going. Who has that negative in front? Well, the x does. Well, then the x goes to the bottom of the fraction. That's what I was trying to tell you earlier. Don't worry about the rules, but it's supposed to multiply. No. If it has a negative in front of it, then that belongs at the bottom of a fraction. Look at this one. Yeah, there's a plus. You might say, oh, it's going to multiply. But again, the y does not have a negative in front. If the y doesn't have a negative in front, well, then it stays on the top. And I understand you're saying, but it says it needs to multiply with x. No, but if they wanted you to do that, they would have put a parentheses around it so that you put both of them at the bottom. No, only if it has a minus, it goes at the bottom. This thing has a plus, then it stays on top. Look at this one. There's a plus. So yeah, I'm going to multiply. So I'll put it on top. And then that's where the z to the 6 goes. So that's why the one thing to remember is if it has a minus sign, just like it did over here, whatever's behind it, right? Or whoever has a minus sign goes at the bottom. The x had a minus sign. Well, then it goes at the bottom. But it's the only one. Again, the only time I would have put all of these at the bottom, because you might say, yeah, but they're all multiplying and it has a negative, is if they put a big parentheses around the whole thing, then that means everybody was at the bottom, but not in that case. All right, so please be careful with the condensing portion. Negative in front means it goes at the bottom. Now, number 3. For number 3, they're changing it up a little bit and saying, well, let's expand the logarithm now. Remember, when we do an expansion, you have to look inside the log. And when I say inside the log, we mean this, right? If I were to put a parentheses like I did earlier, I look in here, and then I notice a couple things. Number 1, there's a 5 in it. There's also an x involved. And we have one more base down there. We have a y involved. So notice the fact that I brought 3 colors into this problem means that when I expand, I should see the word log base 7 3 times. Everybody gets their own log. That's the thing to remember. Yes, even the 5 by itself gets its own log. So if there's 3 things in here, well then look, I should write log base 7, log base 7, log base 7. Too many of you are worried about, well, yeah, but what do I do? You know you have 3 things in there, then write it 3 times. And now just go in order. Look, the first thing there is a 5. Okay, put a 5 there. When I keep reading, the next thing there is an x to the 4. Well, then I write x to the 4. And then the last thing here was the y squared. Well, that's the last thing I read. Well, then that's the last thing I write down, y squared. Now let's connect it all. And if you use the rule that we mentioned earlier, remember, who's the only one, or what's the only thing that's at the bottom of a fraction? It's just the y. Nobody else is at the bottom, just the y. Well, then just the y gets the negative in front of it. The other 2 are next to each other. That means multiplication. Well, then they're plus signs. Again, minus signs are only for things that are at the bottom of a fraction. Plus signs are for when multiplication is happening on the top. Now, technically, we're not done. When you are doing an expansion, we do not want to have power. So you see, the 5 is good. The 5 has no power. But that x has a power of 4. The y has a power of 2. Well, we already know what we can do. According to our rule, we can take that power and bring it down. We can take that power and bring it down in front of the log. So here is officially my final answer. Log base 7 of 5. That one was done. Now this is going to be a 4 log base 7 of x minus, bring down the 2 log base 7 of y. And then that's it. So again, only if it's at the bottom of a fraction, that's the only one that gets a minus sign in it. But the idea is, yes, even a number 5 by itself should get its own log. Now, let's look at this next one here. Practice one more of this type. So again, I look inside. There's an x. There is a y. And of course, there is a z at the bottom. So there are 3 bases, 3 things in this problem. Then I'm going to write the word log base 2. Log base 2 once, twice, 3 times. Why? Because there's 3 letters inside, 3 bases. And of course, the first one I read is x to the 3. The next one is a y. The last one is a z to the 4. And the only one at the bottom of a fraction is the z. So that's the only one that gets a minus sign. The other then, the y then gets a plus. And just like that, we're about ready. But I need to bring down the power. So that 3 needs to come to the front. So now it's a 3 log base 2 of x. Plus, there is no power here to worry about, so I'll just copy it right back down. I do nothing with that one. Minus, and I bring the 4 down for log base 2 of z. Just like that, we're done with this expansion. Again, I don't feel we practice expanding and condensing too much. So that's why I wanted to make sure we showed it one last time before we take the test. And just to finish it off, we're going to do one of our graphs as well. Now, you will do one of each type of graph. There will be an exponential, there will be a logarithm, and then there's going to be an exponential with a base c, just like in our review. So for this problem here, it says we are going to be drawing a log base 4 of x. So just keep in mind a few things. I got to think about the parent function. Now remember, when you're working with the parent function is just this. Parent functions don't have other numbers floating around. Adding, subtracting, no, we don't have any of that. So the parent is y equals log base 4 of x. Now, the biggest thing you have to be careful with today, and this is why you needed to make sure you added it to your word wall somewhere. See, we're drawing a logarithm. When you're drawing an exponential, we said these are the points, the two basic points of an exponential. An exponential is either like a plane taking off, or as you can see right here, it's like a plane landing on these. Now, this right here, remember this parent function is more for this type of exponential. Whenever you have an e, you use the calculator. You instantly just use your calculator to make a table. So when you have e, you use a calculator, make a table. This table, though, is for an exponential function, and it's always 0, 1, and 1 base. Well, I'm not drawing an exponential. I'm drawing a logarithm. And what you have to remember is that when you draw a logarithm, the x and the y change. So here we have a logarithm. These are the points that all parent log functions go through. 1, 0, base 1, but you can't mix them up with this one. They're different. They look the same, but remember, they're switched around. In fact, this one has a vertical asymptote versus a horizontal on the other. So anyways, let's see, these are the points I'm going to use. So all parent logs go through, and we actually have a little table at the bottom here for us, ready to go. All parent logs go through 1, 0, according to what I wrote in my word wall, and then base 1. Well, don't forget, your base is a 4, so 4, 1. So I'm going to start by drawing the parent. 1, 0, 4, 1. Now this is just the parent function. So this is not my official answer yet. There's the parent. Remember, we know there's an asymptote here. All the parent functions go right through the y-axis there. But now let's talk about the moves. So looking at this number here, all we have is a -3. Now remember, this is just a practice one. I know on the test it'll probably have that extra number. But remember, when it says x -3 in the parentheses, look, here's your example. Your word wall has it all. Don't lose out on these easy points. X minus a number means go to the right. So this right here means I'm going to go to the right 3 spaces. And even if you don't know how to draw, we'll at least get these points. Look, it says describe the transformation. Then I'm going to the right 3 spaces. Get the easy points out of the way. Don't lose out on points that the word wall is giving you answers for. You know, if you say, well, I don't know how to draw it, well, don't lose out on this. Now, if I'm moving to the right, now keep in mind there is an asymptote right here, right where my pen is, right at the x-axis, sorry, the y-axis, but I'm moving it to the right 3, 1, 2, 3. So then I do need to draw a brand new one. So we have a new asymptote because I'm going to the right 3, and it's going to be x equals +3. Again, it should say x. So here we go. We said to the right 3. So x equals 3 is my brand new asymptote there, and it's a vertical asymptote. And again, look at how the word wall helps you here. It says it right there. The vertical asymptote is x equals whatever your h was. Well, that's why when it's x minus h, you went to the right, so it's positive. That's why we wrote +3. State the, okay, well, now I need to draw it. So I'm moving everybody to the right 3, 1, 2, 3. There it is. 1, 2, 3. There we go. And so here is my graph. This is the one they wanted me to draw all along, that red one. So state the x-intercept. Well, it's right here. We could see it. It's the number 4. So we write 40. Remember, get into the habit of writing it as a point. And then the next two questions, look, domain and range. Sadly, we always get people who get this question wrong. One, because they still haven't understood what that means. But what I mean by sadly is people get it wrong. This is a logarithm, right? It says log in it. Logarithm, domain and range. Look at what it says for range. Your range is all real numbers. It doesn't even give you an option for anything else. Your domain is x is greater than whatever the h was. Well, my h was the number 3. So when I'm looking at this one here, state the domain. Well, it says x equals 3. So I'm going to write x. I'm going to write the 3. And because my graph is to the right of this pen, then that's why the word wall says x is greater. And then according to the word wall, my range is always all real numbers. So there are points that you should not be missing on this test, especially when the word wall had this answer for me. All real numbers. Look at that. Logarithm, range, all real numbers. No excuse not to get these points. All right. So remember, this is not the entire test. This is just to kind of get you thinking again about the math. Right now, you are going to take the test on Elluminate. You can ask clarifying questions online if you have them. You can continue to ask for your final check. And then, of course, make sure that you do the last 4 problems. The last 4 problems are on paper only, and that's where the graphs are going to kick in. So if you want to get these out of the way, make sure you attack the last page of your test first. All right, good luck, everybody. Take your time. You can only use your word wall, and of course, you can only use Desmos Scientific, which should open for you automatically. All right, have a wonderful day and good luck.